In an era of fly-by-wire attack jets and precision-guided munitions, unprotected infantrymen are especially vulnerable. Yet their role on the ground is as vital as ever. Today they ride into battle protected by vehicles as sophisticated as anything they might face on the modern battlefield. When tanks first appeared on the battlefields of World War I, they were lumbering, slow machines. By the end of that war, military strategists had learned that tanks were at their most effective when they were supported by attached infantry units. During the 1920s and 30s, the speed of tanks increased dramatically. Newer tanks raced across rough terrain at speeds of up to 30 miles per hour, nearly 10 times faster than infantry could maneuver. A solution was needed to keep the infantry with the tanks at the front of the battle. Trucks were a possibility. However, they offered no armored protection and could only travel effectively on roads. For infantry combat, more capable vehicles were needed to carry out what is called today combined arms tactics.
The capabilities of faster tanks became more and more preponderant during the 1920s and 1930s, and then we see the development of vehicles that can keep infantry under armor and up with those tanks as they go deep into the enemy's rear.
The combined use of tanks, infantry and artillery was first seen in the Second World War, with the deployment of infantry combat vehicles such as the U.S. Army's M3 half-track. Its rear track assembly gave it better mobility than trucks using wheels alone. And its light armor protected the infantry squad inside from enemy small arms fire. It also gave added firepower to the infantry squad by adding a 50 caliber machine gun. However, it provided no overhead armor protection since the added weight would have been too great a burden for the vehicle. The infantry fighting vehicle evolved slowly after the war. The Soviet BTR-152 of the early 1950s was little better than the wartime half-tracks, essentially a truck with armor plating. But tank technology was moving ahead faster than vehicles like these. Clearly, additional armor and mobility was needed. In the 1960s, a new generation of infantry vehicles emerged, called APCs, or Armored Personnel Carriers. The U.S. Army's M113 was typical of this type of vehicle. These fully tracked vehicles had greater mobility than half-tracked vehicles, and provided the troops the security of full armor protection.
Going to the full track gave them a much better off-road capability than the half-track design did. And let's face it, with full track versus half-track, on road you really don't have that much difference in capability. With the wheel, you're subject to tires getting punctured and to the fact that you're going to have less off-road capability without the full track.
The M113 was the first modern battle taxi developed to transport infantry forces into combat in concert with the battle tanks. Once in position, the infantry would dismount and fight on foot. The M113 family of vehicles is the most widely produced American armored vehicle of all time, with over 80,000 manufactured. It is used not simply for transporting infantry. The M113 has had more than 40 major variants, and with over a dozen still in use, M113s continue to serve in many combat support roles, such as its use as an ambulance to carry wounded troops away from the front. The M113 is also used as a tank hunting vehicle, armed with the TOW missile. The most recent variant has its TOW missiles mounted in a special armored launcher, so that the crew stays protected within the hull of the vehicle. When ready to fire, the missile launcher can be elevated above the roof, allowing the crew to position the vehicle behind a hill for further protection. The M113 has been widely exported around the world, serving in over 50 countries. In the 1991 Gulf War, the M113 not only served with the U.S. Army, but with the armies of other coalition forces, including the Egyptian and Saudi armies. The M113 is built of aircraft-quality aluminum, which has the strength of steel, but a much lighter weight. Its light weight permits a relatively small engine to power the vehicle while transporting a large payload cross-country. The most challenging requirement for infantry vehicles comes from Marine units, with their need of transport across terrain as well as water. The U.S. Marine Corps pioneered amphibious infantry vehicles, which they called Amtraks. In the 1970s, they developed the Amphibious Assault Vehicle 7, which has undergone continual modification. It is larger than the M113, since greater size means increased buoyancy. The AAV-7 easily floats even in heavy surf conditions. Its propulsion in water comes from water jets located at the rear of the vehicle. On land, it relies on conventional tracks. The AAV-7 provides great armored protection to Marines during amphibious assaults. But with a top speed of 7 knots in the water, it leaves the vehicle vulnerable to enemy attack for extended periods. And its 20 miles per hour land speed does not allow it to keep up with the Abrams main battle tank. The U.S. Marine Corps developed a novel solution in its new Expeditionary Fighting Vehicle, or EFV. This advanced amphibious assault vehicle utilizes a bow plane positioned at the front, which causes the 30-ton vehicle to rise out of the water as if on water skis. Skirts at the side of the vehicle can be lowered to cover the tracks to eliminate a major source of drag. With a powerful turbine engine, speeds of well over 20 knots can be achieved, even in rough surf. And it can cruise at over 30 miles per hour on land. Not only is the EFV faster on land and in water than the AAV-7, but it also has better armored protection, making it the battle taxi of choice for the U.S. Marines. In the mid-1960s, a new approach to infantry vehicles began to emerge. The Soviet Army, convinced that modern land warfare might involve nuclear weapons, began designing an infantry vehicle that would allow the troops to fight from within the vehicle, rather than merely being transported to the front. While armored infantry vehicles of the day offered limited protection from the hazards of radiation and blasts, the troops were incapable of fighting from inside these vehicles. Firing ports were added, and the vehicles themselves were fitted with weapons, such as low-pressure guns or anti-tank guided missiles. The Soviet BMP-1 was the first of these new infantry fighting vehicles, or IFVs. In the mid-1960s, the German army began development of the Marder. Like the BMP, the Marder allowed the crew to fight from within. The Marder is heavier than the BMP, and so it cannot swim. Instead, the designers fitted it with a retractable snorkel that allows it to wade across rivers. Like most infantry fighting vehicles, the Marder is cramped and noisy inside. Infantrymen appreciate the armor protection that such vehicles offer, but they exit the vehicle with some relief. In the early 1970s, the United States Army began searching for its own infantry fighting vehicle. FMC Corporation developed enhanced versions of its successful M113. These had a turret as well as firing ports for the troops. Although such a vehicle had distinct advantages over the older M113, it was still not enough for the U.S. Army. By the late 70s, the Army sought an armored troop transporter capable of keeping pace with their new M1 Abrams tanks without sacrificing armor protection or offensive capability. In 1981, these needs were met with the Bradley infantry fighting vehicle. The Bradley offered three critical improvements over the earlier M113. It was fast enough to keep up with the Abrams tank in combat conditions. It represented a fundamental leap forward in firepower, and it was more heavily armored than any previous infantry transporter. Unlike the M113 series it replaced, the Bradley is not simply a battle taxi. It is a sophisticated weapons platform capable of providing tremendous firepower and direct support of the infantry it carries. The 25mm Bushmaster cannon is stabilized, allowing it to be fired while the vehicle is moving. And the gunner can choose between high explosive and armored piercing rounds in single or multi-shot modes. In addition, the Bradley is fitted with a thermal imaging night sight, which allows it to fight day or night. An infantry squad in a Bradley has 7 men, 2 of them armed with squad machine guns and the rest with assault rifles. In addition, the squad can carry a Dragon anti-tank missile, as well as anti-tank rocket launchers. But the Bradley's most powerful weapon is its turret-mounted TOW missile launcher, capable of destroying nearly any tank on the modern battlefield. During the 1990s, Europe and the U.S. switched their attention from firepower to protection. Infantry vehicles, even the thickly armored Bradley, are still vulnerable to anti-tank weapons, such as rocket-propelled grenades and anti-tank missiles.
Another one.
The real barrier to more heavily armored infantry vehicles is cost, not technology. Infantry vehicles, should they be armored as heavily as tanks, would cost as much as tanks. Yet improvements in infantry protection continue. The Bradley M2A2 adds additional armor to protect it against autocannon fire of other IFVs and enemy anti-armor weapons. Tracked vehicles are more complex and expensive to operate than wheeled vehicles. In some areas, such as in deserts, urban areas, or dry plains, the terrain is suitable for either type of vehicle. For economy's sake, many armies have adopted wheeled infantry vehicles. These have little in common with the wheeled armored vehicles of the Second World War, having much more sophisticated all-terrain features. A good example of this type of infantry vehicle is the South African Rottle infantry carrier. The Rottle operates in dry terrain where a wheeled vehicle layout is optimal. Mines have been one of the most common threats to South African armored vehicles. Therefore, the hull of the Rottle has been designed to better withstand mine damage than conventional armored vehicles. While the vehicle may be damaged beyond repair, this feature can significantly reduce casualties among the crew. The French Army uses both wheeled and tracked infantry vehicles. Their tracked infantry vehicle is the AMX-10P, while their wheeled infantry vehicle is the Renault VAB. The heavy AMX-10P is used by mechanized forces committed to European defense, while the VAB is generally allotted to units of the Rapid Deployment Force. The AMX-10P is the support and freight vehicle of the mechanized infantry units. This tracked amphibious armored vehicle transports a group of 9 men in addition to the driver and gunner. It has great autonomy and excellent land and water mobility, which allow it to cross flooded areas. Its armament enables it to engage light armored tanks and low-flying aircraft. In 1998, France deployed the AMX-10P to the Balkans in order to help stem Serbian aggression in Kosovo. The VAB wheeled infantry vehicle uses a sophisticated independent suspension system, which provides greater cross-country mobility. Compared to other IFVs, the VAB is quite spacious, able to carry up to 12 troops into battle. Like many wheeled armored vehicles, the VAB can maneuver across small water obstacles such as rivers. The VAB's light weight makes it very easy to transport by aircraft, thereby giving it additional strategic mobility. The VAB has also been extensively exported and saw combat duty during the 1991 Gulf War in both French and Qatari service. Although the U.S. Army showed a preference for tracked vehicles as far back as World War II, the demands of 21st century combat have led them to adopt a wheeled vehicle as the centerpiece of their brigade combat teams. The 8-wheeled Stryker is the first new Army vehicle since the Bradley IFV was introduced in the 1980s. The Stryker is based on the LAV-3, but its similarities with this combat vehicle end with its wheeled configuration, diesel engine, and 6-speed transmission. The Stryker has an advanced information management system, linking it with other vehicles and higher command, creating a digital battlefield communications system. Real-time combat intelligence is available as each vehicle automatically shares its GPS location data. The crew is protected by advanced steel and ceramic armor, more than twice as strong as the armor on an M113. Stryker crews can vary their tire pressure from within the vehicle to provide greater traction or greater speed depending on conditions. And the run-flat tires will perform even if punctured. The Stryker combat brigades were first deployed in November 2003 in support of Operation Iraqi Freedom and subsequently served in Afghanistan as part of Operation Enduring Freedom. As innovative as the Stryker is, the real wave of the future can be found in the U.S. Armed Forces' latest efforts to develop hybrid-powered combat vehicles. Two extraordinary examples of this endeavor are the Shadow RIST-V and the AHEAD 8x8 programs. The RIST-V, for reconnaissance, surveillance, and targeting vehicle, was the first to utilize hybrid electric drives and in-hub motors. One requirement was to have a vehicle which could be easily transported by the V-22 Osprey. The RIST-V's compact design and folding suspension allows for just that. It is also designed to carry a payload of 3,000 pounds with a crew of 6, as well as travel up to 70 miles per hour. The Advanced Hybrid Electric Vehicle, or AHEAD 8x8, goes even further in exploring the possibilities of hybrid design. The key technologies include magnetic motors installed in each wheel hub, advanced pneumatic suspension, and innovative hybrid wheeled or tracked steering. Its in-hub motors provide the high torque and exceptional range required for the most severe military applications, while the compressed air suspension allows for superior ride quality, cross-country mobility, and height control. And the AHEAD's unique capability of being able to switch between a wheeled and tracked configuration give it an extra degree of tactical mobility. The application of in-hub electric drives and hybrid power dramatically alters the vehicle's overall design. The removal of conventional transmissions, bulky suspensions, and drivetrains significantly increases the total internal volume of the vehicle, resulting in greater space for payload and crew. The AHEAD can carry a payload of 8 tons and has enough space to accommodate up to 12 crewmen. Together, these new technologies and designs promise to revolutionize the future of combat vehicles. Although infantry warfare has changed dramatically over the years, the basic job of the infantryman has not. An infantry squad may now ride safely into battle, but they are expected to retain all of the traditional fighting skills of earlier foot soldiers. Technological advances have allowed more infantrymen to survive on the modern battlefield, but many new challenges lie in store for the infantry's combat vehicle.